Hello, welcome back to Math with Patrick. Today is February 4th, and we're solving the 35th problem from this Daily Epsilon calendar. Okay, let's try it out. Looks like we have two of these irrational radical numbers, like things with square roots on them, added together, and it's going to be something times the square root of 3. So ultimately my goal is to, show that this is 4 root 3, though I'm not quite sure how to do it yet. I have an idea. I'd rather get rid of these square root signs, and one way to get rid of square roots is to, square what you got. And I just have a hunch, I have a feeling that by squaring my value, I'm gonna get something that might look like this. So that's my plan, and let's see if it works out. So let's see, squaring it. Squaring something just means multiplying it by itself. So you could imagine having the same thing just repeated over here. And when you multiply two binomials, as in a binomial is something plus or minus another term on the inside. When you multiply binomials together, you got to be a little bit careful on how you do it. One strategy is to do the first two terms multiplied to each other, then the outside terms, then the inside, and then the last. So each of the four terms in both binomials kind of need to talk to each other in this multiplication. So the first two terms are going to be this number squared, and squaring something that already has a square root on it just kind of cancels them out. So I'll get a 16 plus 8 root 3 for my first two terms multiplied. Then to do the outside terms, I will do these two multiplied by each other. And when you multiply radical numbers, you can just kind of multiply the inside parts and shove them together underneath the same square root. So I'll have the square root of, and then both of these radicands, the underneath part, both of the radicands multiplied to each other. And then when I do the inside terms, it's actually just the same two terms anyways. So just kind of painting that picture again, the outside terms would be this 16 plus 8 root 3 multiplied by the 16 minus 8 root 3. And then when I do the inside two terms, it's just this times the same one, or rather this times the first. So I basically am doing this multiplication twice. So let me just put a 2 here. I have twice this amount here. And then finally, I need to do last times last, and kind of like this first one, if I multiply a square root of something times the square root of that something, it'll just be the underneath value like that. Okay. So squaring this number gave me something longer and a bit more complicated looking, but I'm hoping that I have some nice cancellations. Like for example, this plus 8 root 3 and this minus 8 root 3 cancel out. And then I'll combine the 16 with the 16. So I have 32, and then these cancel out here and here. Plus 2 times, and then I'm hoping I get some nice cancellations in here. Well, it looks like I have another binomial times a binomial, so I'll run through that distribution or foiling method again. 16 squared, what's that? Is that 256? I'm just kind of going off of my knowledge of powers of 2. Let me just double check. 2, 4, 8, 16, 32, 64, 128, yeah, 256. Okay. So that's the first. Then the outside and inside terms are going to cancel. Yeah, because I have 16 times a negative 8 root 3, and then I'll add a positive 16 times 8 root 3. So the outside and inside terms cancel out. So I'm just left with minus, and then 64 times 3. So when I multiply these two together, I can combine the 8s, and then root 3 times root 3 makes just a 3. Okay. 64 times 3, that's 192. And I'm really hoping that this square root simplifies nicely. Let's see. 256 minus 192, just some subtraction here, borrow that. 15 minus 9 is 6. 1 minus 1 is 0. Nice. Okay, good. So I get 32 plus 2 times root 64. Okay. root 64, what times what is 64? That gives me an 8. And then 32 plus 16 gives me 48. Okay, so by squaring this, I got the number 48. That's pretty cool. I'm just going to call this first part, how about a, just to give it a variable. And so 48 is equal to a squared. And, well, if I just kind of hit both sides with the square root, I know that a is just the root of 48. So according to this problem statement, this right here is the square root of 48, and it's equal to x times root 3. So I should just simplify this until I get something times root 3. Okay. So when I simplify these square roots, I just like to list off all the factors that I can, and a factor tree is super helpful for this. So 48 is 4 times 12. I can split up the 4, and I can split up the 12, and then I can split up the 6 one more time. So 48 is 2 times 2 times 2 times 2 times 3. That's all of these prime numbers at the kind of bottom parts, or the bottom part of my factor tree. So all of these prime numbers multiplied up give me 48. And when simplifying square roots, if you see any pairs, they can like escape the square root sign together. So both of these 2's turn into a 2 on the outside. These two 2's turn into another 2 on the outside. And then this lonely root 3 doesn't have a friend, doesn't have a pair, so it's stuck on the inside. Okay, well, 2 times 2 is 4. And now I can see that this value, which I at one point called root 48, it is also 4 times the square root of 3. And so that means that this x right here has to be a 4. Cool. Well, I'm glad that squaring it at the start was the right step, because if it wasn't, then I'd just go down that rabbit hole and I'd have to try again. But looks like after squaring the initial value, I was able to simplify some stuff, simplify some square roots, and ultimately end up at that 4 for today. Okay, well, hope you enjoyed my solution, and I'll see you in the next video.